Hello class, and welcome to Chapter 10, which is about real numbers and right triangles. Our first lesson from this chapter is going to focus on squares and square roots. By the end of today's lesson, you will be able to identify and solve different square roots. So, perfect square is a number that results in from a number to the second power. So what that means, for example, is if I take 7 and I say 7 to the second power, the answer to that is 49. 49 is the perfect square. So whenever you take a number and square it, that answer is a perfect square. You could have done 152 squared. And when you get that answer, that's going to be 23,104. This is also a perfect square. So any number that's the result of squaring is a perfect square. The square root is one of the two equal factors of a number. It's for every positive number, there is both a positive and negative square root. So what that means is this symbol that next vocab word, the radical symbol, indicates the positive square root. So you're probably just used to calling this square root. We actually call it a radical. So this indicates a positive square root. So if I was going to say the square root of 16, for example, that answer would be 4. But what it's saying up here with the square roots is you can take the square root of 16 and get the answer of 4, because 4 times 4 is equal to 16. Or you can have the negative square root of 16, which is going to give you negative 4, because negative 4 times negative 4 is also positive 16. Now the one thing that you can't do is take the square root of negative 16, because the only way to get to negative 16 is negative 4 times positive 4. And negative 4 and positive 4 are not the same numbers. So you can't take the square root of a negative number. It's not possible because we can't split it into two equal pieces. But you can take this positive square root, 4 times 4, or negative square root, negative 4 times negative 4. So I just want to go through and make a list of the perfect squares for you. We're going to use the first 15. These are probably ones you should have memorized. Obviously, you'll be able to plug them into the calculator, but it's super helpful and it'll make your life quicker if you have these memorized. So the first perfect square is 1, 1 times 1. The next perfect square is 4, 2 times 2. Next perfect square is 9, 3 times 3. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So these are going to be ones that you're going to see probably relatively frequently in this chapter, as well as when we get into our radical part of algebra next year. So it'll be really helpful if you can remember these perfect squares off the top of your head. When you are finding square roots, our job is to figure out what the factor is, paying attention to what sign it has. So the square root of 49, when it's written as just the square root, that's looking for the positive answer. So this one is just 7. This next one has a negative sign in front of it, so that's looking for the negative answer, because negative 4 times negative 4 is still positive 16. This is a new symbol that we haven't really discussed. This means positive or negative. That's why it has the plus and the minus. So our answer to this one would be plus or minus 10. And then this last one, as we discussed on that first slide, you can't have the square root of a negative number because negative 9 times positive 9 is negative 81, and negative 9 and positive 9 aren't the same answer. So this would be a no solution problem because you cannot take the square root of a negative number if it's on the inside. So be careful that you're paying attention to the differences between these two, whether the negative is on the outside of the radical or on the inside of the radical. Go ahead and try this one on your own. We have an answer of negative 5. The next thing we're going to talk about is estimating square roots. So this is, as we know, if you go back to that original list of perfect squares, 33 is not on our list. So what we want to do in order to estimate is we're going to look and see between which two perfect squares does 33 fall. So below 33 is 25, and above 33 would be 36. So our estimate here is going to be that the square root of 25, so 5, is less than the square root of 33, whatever that answer is, which is going to be less than 6, because 6 is the square root of 36. So essentially what this is saying is that your answer is in between 5 and 6. The other thing you want to look at is which one it's going to be closer to. So 33 is 8 spaces away from 25, but it's only 3 away from 36. So the last part of this would be that it's closer to 6. So it's probably like 5.8 or something. We aren't figuring out the actual answer right now. We're just estimating, so approximating what our answer is going to be. Again, same kind of process works if we've got the negative sign. With the negatives, you need to be careful because remember, our bigger negatives are actually our smaller numbers. So this is in between the square root of negative 144, that's the smaller option, and negative 121, that's our bigger option. The negative square root of 144 is negative 12, which is going to be smaller than the square root of negative 129, which is going to be smaller than negative 11. So essentially we're saying it's between negative 12 and negative 11. Looking again, to get from 144 to 129, that's a difference of 15. To get from 129 to 121, that's a difference of 8. So we would say closer to negative 11. So you look for the square root below what you're estimating, you look for the square root above what you're estimating, and then you determine which one it would be closer to. Go ahead and try this one on your own. So we got between 144 and 169, and then it's going to be between 12 and 13, closer to 12. So that's what we do when we estimate for square roots that are not perfect squares. Now to actually solve for square roots that are not perfect squares. And this is going to be using your calculator. So I just want to go over what this would look like on the different calculator options that you have. If you are using the calculator that we use in class or one that's similar to it, first you're going to want to hit this blue second button, and I'm going to highlight that a little bit better. You're going to want to hit that blue second button, and then down here and hit that X squared button. So the blue second and then the X squared button. After you do that, you're going to have that nice little square root sign. You type in whatever number you want. So you could type in 49, and then you would hit the Enter key, and it's going to give you the answer of 7. A couple other calculator options. If you're using that online one that I gave you that's posted at the top of your Google Classroom, it's going to be the same process. The buttons just look a little different. So you're going to hit that second button, and then after you do that, you're going to hit the X squared button down here, and that's going to give you that square root. Again, you would type in the number, so 49, and that square root would keep extending over the top of it. And then once you hit enter, it's going to spit out that answer of 7. If you are using the calculator on your computer or on your iPhone, if you are on your computer, you open the calculator app, and then you're going to want to double check. If you don't see this bigger version and you just see the small version that cuts off and looks like this, what you need to do is go up to the menu bar and pick the view option and change that to scientific. If you're on your iPhone, when you open your calculator app, instead of having your phone vertically, you need to tilt it horizontally, and it will bring you up to this expanded menu option. On the computer or on your iPhone, you type in the number first. So you type in 49, and then you would hit this square root. Make sure you hit the one with the 2. That's the square root. The one with the 3 is the cubed root. This is not something we use. The one with the y and the x is a bunch of different root options. Again, we don't use that. You want to make sure that you're using this square root option. You hit this key, and then the answer of 7 will pop up. So that's just a quick rundown of how you can do the square root on your calculator. So now, using whatever calculator you have, you would type in square root of 27. And that's going to give you an initial answer of 5.196, blah, 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 blah. What we need to do is then be careful in our rounding. If we are rounding to 2 decimal places, we look to the third. The 6 tells me to go up. So instead of having this be 0.19, I go up to the next number, and that would be 0.20. If I come over to the next one, I type square root of 79 into the calculator. You do not type in this plus minus thing. It's not possible to type it into the calculator. So you just type in square root of 79, and you're going to get an answer of 8.88888, etc. And that's where you're going to put the plus minus back in. Again, we need to pay attention to our rounding. So rounding to 2 decimals, this third place, the 8, tells me I need to go up. So instead of 88, I'm going to make it plus or minus 8.89. And then on this last one down here with the negative 14, again, don't type in the negative, just type in the square root of 14. And when you do that, you're going to get 3.741, etc., etc. This is where you would put that negative back in, and then you need to do your estimating to 2 places. The 1 tells you to round down, so the 74 is going to stay as negative 3.74. So when it actually asks you to estimate with a calculator, it means to get the decimal value. If it asks you to estimate without the calculator, then it's going to be that in-between value, which I had previously shown you. Go ahead and try this one on your own. We end up with 8.83 as our rounded estimate for this square root. Last thing we're going to do is apply some square roots within equations. So on a clear day, the number of miles a person can see to the horizon can be found using the formula D is equal to 1.22 times the square root of h, where D is the distance to the horizon in miles, and h is the person's distance from the ground. The observation deck of Seattle's Space Needle is 520 feet high. How far to the horizon can a person standing on the observation deck see? So what we need to do is we need to take our given information, our important piece of 520 feet, and plug that into our formula. So we're going to say distance is equal to 1.21 times the square root of 520. Now the question is, where do square roots fall in PEMDAS? PEMDAS-wise, square root gets treated like an exponent. So if there was any parentheses in this problem, I'd do those first. I don't have any parentheses. Then you move to exponents. Square roots is part of a subcategory of exponents. So you would solve the square root of 520, and you would get d times 2.2 times 22.803, etc. Now, you can write down a rounded answer here, but you don't want to clear it out of your calculator. So in your calculator, then, you would keep that answer, hit the multiplication sign, and then say times 1.22, because we only run a round at the very end when I get my final answer of 27.82 feet. And that's how far that they can see off, not feet. That should be miles for the distance. So that's 27.82 miles that they can see off into the distance. Go ahead and try this one with that same equation on your own. So you plug in your 55, solve that square root, multiply by 1.2, and you get 9.05 miles. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.